Alright, so today we're going to learn about transformation, SPM, mathematics. So under transformation, we have three isometric transformation, which is translation, rotation, and reflection. So what's transformation? Transformation is pretty much how an object is moved to an image. So basically, let's say ABC is my object and A prime, B prime, C prime is my image. So what's the translation? So we can see the similarities that it's a similar shape, it's similar direction, but it's just in a different position. So basically, object is moved until here. Alright, so what's the translation? To determine the translation, we have to know how it's moved. So I'll just pick a point, and here's the same point, right? So move to the right 2, move up 2. So I will write this as 2, 2. For checking purposes, I can use this point and it would be the same, right? Okay. So next is reflection. So reflection, the distance of the object and the distance of the image from the axis of reflection are the same. So this would be the axis of reflection, and this distance will be similar as this, right? Okay. So next one is rotation. What's rotation? So in rotation, it's important to understand the center of rotation and clockwise, whether it's clockwise, anti-clockwise, and the degree. So all the points of this object would turn at a fixed point, also known as the center of rotation, through a same angle in the same direction. So basically what's happening here is, right, so here's the object and here's the image. What happens here is it rotates 90 degrees from the origin clockwise, because object to image. Always remember that out of all this isometric transformation, it's all object to image, and how the image forms from the object, whether it's through translation, rotation, or reflection. Right? So try a few questions. So right now this is my object. I'll color it with another color. Green. Here's my object. Okay, that's very right. Okay, object. So what's t? So the first question is t power 2, which is tt, right? But what's t? They have given it. They say translation is 3, 4, which means it moves to the right 3 and then moves up to 4, right? So where's my object? Here. I won't really care about the other things, so I'll just find it on my own. Okay, so this is my first point. You can pick any point you want, but I like that one, so I will 3 to the right and 4 up. 1, 2, 3, 4. So this is my first image. My first image would be figure I. But they need 2t, so both translation processes undergoes consecutively. So we'll undergo the translation 3, 4 again from figure I 1. Right. So the final image I have is E. So under t transformation, my shaded region will form an image of E, which is this. Right, so next. Next is R, which again is R. R would be clockwise rotation of 90 degrees about the origin. So same, it's the same object. I put as a shape figure. So RR, 90 degrees above, about the origin. This time I'll take this point. So how do we determine what image will form from a rotation of 90 degrees? So here's the origin. One way I find really effective is through this. So from the origin to this point, moves up 5, and then moves to the right 1. So one way we can determine that is by drawing, because it's 90 degrees. So here's 90 degrees. So 1, 2, 3, 4, 5, and 1. So this is our first image. Figure 3. So, but it will undergo another time of rotation. So we do the same thing again, but only from figure 3. So what happens is 1, 2, 3, 4, 5, and 1, and therefore F is obtained. So under RR transformation, my image is F. There. So next one is TP. This is slightly different from T square or R square because it's two different letters. One way we read this is through P and T. Although it's written TP, you have to write it in TP, but it actually P is the first transformation and T is the second. So remember that. Alright. So the same object, first it undergoes P. What's P? Reflection in the y-axis. So reflection is where the distance is similar, and this is my y-axis, right? So my image would be figure 2. And then I'll undergo translation 3, 4 again from the image. So let me get this away. Right. So 3, 4. 1, 2, 3. 1, 2, 3, 4. So my image is D. Right. So it's pretty much similar for D and E, but I'll go to F. I'll go straight to F. Okay. So F is R, T, which is T first, then R. So the shaded figure is this object. And what is T again? Translation 3, 4. Again, 1, 2, 3, 1, 2, 3, 4. So my figure is figure 1. But then it undergoes R. What's R? Clockwise rotation of 90 degrees about the origin. Okay. Again, so this is my new object now. So clockwise from origin. So I'll move up 9. I'll choose this point. I'll move up 9. I'll move to the right 4. So again, 90 degrees. I move up 9. I move down 4. So my image is C. So there you go. That's the answer. And if you would like to do D and E, the answer is figure A and figure B. Right. So 3.1b subtopic. We talk about enlargement. So enlargement, what's important is there is a fixed point called the center of enlargement, and there's a ratio. It's called the scale factor. One way to determine scale factor is by using is by measuring this. So from here to here, it's 6 minus 3, so it's 3, right? And here to here, 2 minus 1, 1. So scale factor can be calculated by image over object. So I'll put 3 and 1, and right, so this is my image, this is my object, and I'll get 3. So this is a scale factor of 3 from the center of enlargement. Where is my center? This would be the origin, because if I draw a line, it will actually intersect at the origin. Right. So let's do this question. The diagram is drawn on the Cartesian plane. Okay, so we'll continue with enlargement. So here's my object, the green color, and then the question wants E squared. So it's EE, right? And EE is enlargement with center at the origin and a scale factor of 2. So when there is enlargement, a way we can do is this. So I'll choose this point, which is 2 minus 1, and I'll multiply it by 2, and this would be 4, negative 2, which is figure 1. So from the object, when it undergoes transformation E, it will produce figure 1 as an image. And from figure 1, it undergoes transformation E again, and we don't have to care about this anymore. And I just have to multiply this and this again. So it's 8 minus 4, and it's figure C. There. And we have our answer. So for B, it's EP. So what's P? Reflection in the x-axis. So in the x-axis, figure 2 will be produced, because both of these are similar lengths. So right, and then we're going to go transformation E. So from P, figure 2 will be produced. So I'll choose a point. Let's take this, and the enlargement is a scale factor of 2. So my coordinates of this point would be 0, 3, which when you multiply by 2 is 0, 6, which is this. So therefore my new image is D. Right, next, ET, singular T. So what's T? T is translation minus 3, 4. So from the object, minus 3, 1, 2, 3, 4, 1, 2, 3, 4. So it's figure 3. Okay, why is it minus 3? So one thing you gotta remember is that here's the x, here's y. So for x, if it's going forward, it's a positive number, and if it's going backward, it's a negative number. Whereas for y, if it's going upwards, it's a positive number. If it's going downwards, it's a negative number. Yeah. So okay, we'll go back to this, and the next one is E. So right now I'm at, okay, let's remove this. So right now I'm at negative 1, 3, and I'll multiply that by 2, and I get negative 2, 6. and I'll get figure A. So this would be my image under ET combined transformation from my shaded figure, which is this one. This. Right. Okay, next question. ER. So what's R? R is reflection in the x-axis. Reflection in the x-axis, which is this. This is the x-axis, and which means I'll get figure 2. And then E. Again, we'll use the same way. I'll just pick this point. That's right, and it's 2, 3. Multiply that by the scale factor, which is 2. And 4, 6. 4, 6 is here. So that will be my final image, which is D. Right, next. So next we're going to learn how to draw an image of an object under a combination of two transformation. So for example, we'll do A. So what's A? 2, -3. So as I said, if it's a positive, you move to the right, and for the number below, if it's a negative, you go down, right? So from this object, I'll choose a point. I'll pick a point, right? 1, 2, 1, 2, 3. So it's here. So here's my C prime. And you can do that to other points, or you can just draw it if you're confident enough. So that's my first image, but it undergoes T translation twice. So from the first image, I'll undergo another translation to -3. Again, I'll choose this point. 1, 2, 1, 2, 3. So we'll end up here. C prime. And this is my final image. So as long as you give this two answer, you'll be correct. Right. So that's the first question. Next, we'll do TR. So what's TR? So the first thing we undergo, the first transformation is R and then T. So what's R? Clockwise rotation 90 degrees about origin. So clockwise is this way, 90 degrees from origin. So this is the origin. I'll pick this point. So it went up 1, goes to the right 2, 90, 1 to the right 2. So here's my point D. So because rotation is kind of messy, I'll do a few points. Let's get rid of this. So let's choose B. I'll move up 3, move to the right 1, 90 degrees, move up 3, move to the right 1, and here's my B prime. Right, so I think I have enough points to understand how does it look like, and I'll draw it out. Right, so here's my first image. So what's the next? So that's my rotation. What's the next one? RT translation 2 -3, and that would be just like this. And this would be the final image, which I would label A prime prime, D prime prime, B prime prime, C prime prime, as they want you to label it that way. Right. And here's your answer. Okay. Next one, we'll do RP. What's RP? so P is reflection on the x-axis. This is the x-axis, so reflection, which is this. Right? And then the second, which is rotation clockwise 90 degrees. We'll do the same way. Move up, down 3, 90 degrees. Move up, 3. Right. So that's my point. Again. I choose this point. 1, 2, 3, 1, 2, 3, 90, 1, 2, 3, 1, 2, 3. Okay, that's not a good point to choose. So pick another point. Right? 1, 2, 1. 1, 2, 1. Right? So we have it now. And just in case, we'll just take this one. So there we have our final image, which you should label, right? So let's label it. Right. So we continue with the next one, ER. So first R is rotation. So again, rotation. This is A prime. Just do all at once. B prime, C prime, D prime. This is my first image under R, and then E, it would be enlargement of center with center with a scale factor of 2. So similarly, we use the method we used before that. So what point is this? 2 minus 2 negative 1. So we'll double it, which will be 4 negative 2. So let's see, 4 negative 2 will be here. Right, we'll pick another point. I'll choose 3 negative 3. So it's 6 negative 6, 6 negative 6. Right. So we know it's this shape. And again, we'll take this. 1 negative 2. 2 negative 4. 2 negative 4. Right. So here's our final image. Remember to label it, okay? Right. So the next one, PE. PE. So enlargement. Again, we'll use the same method. 2, 1, 4, 2, 4, 2. Right? This is the 2, 1, right? Here's point. 1, 2, 2, 4. We'll just take 2, 4. So we'll just draw this, and then we'll take this point. 3, 3, 6, 6. And here's our first image, and then P, reflection on x-axis. Remember to label it. I'm not labeling it right now, so I'll get like 1 mark less. Right, so 1, 2, 1, 2. We'll do the reflection. So how you can do it is you calculate how from the x-axis or your line of axis, what's the distance between a certain point and the line of your reflection. So continue with this. Right. So this would be my final image. And we'll do the last one, ET. So it's T and E was T again, to translation. Right, here's the first image. And then the next image would be enlargement. So enlargement from origin. Alright, so again, we can use the method. Multiply that by 2. Again this. And there you go. Still have one more point. There you go. And this is our final image. So the next subtopic will be learning about how to state a coordinate without actually drawing it, which is a lot faster. So, alright, here's our image. 3, -2. And then it goes A, right? The first question is TT. So and it goes 2 times of translation. So -4 and 2. So an easy way we can count it is by using, you can just do it by adding it up, right? So x, the x coordinate plus x coordinate and y coordinate plus y coordinate. So it is pretty much like this. Where we can find out. Therefore, by using this, we can find our first image, which is -1 and 0. Right? So from -1, we're going to go another translation. So we'll add up. And we'll get -5. And 2, okay, 0 plus 2, 2. So this will be our coordinate of our final image. So what if we're gonna go to P twice? So reflection in the x-axis, right? So reflection in the x-axis, one thing we have to understand that it's, so here's the line, this is our x-axis, this is our y-axis, right? So if a number is over here, when it undergoes reflection on its x-axis, this image will form. So this will be repeating. until you finally stop, right? And the only value that changes is your y value, because it goes from positive to negative, then positive, and negative again. But your x value stays the same, right? So there's a formula for this actually. If it undergoes reflection in the x-axis, your answer would be, your formula would be this: x minus y. Pretty much that. So how do you get your answer? Which would be, your first image would be 3, 2. The second image would be 3 minus 2 again. So that's about it for reflection. Alright, so we go to R. What's R? Clockwise rotation of 90 degree about the origin. So for rotation, it's better that you draw it out, but if you do not have the time, it's good that you memorize this, but I don't think the exam questions will give you the center of origin, the center of rotation at the origin, because this formula is mostly for the origin, right? And it's 90 degrees. But this formula can be used to determine the clockwise rotation on 90 degrees at the origin. So your first image would be -2, -3. Second image, -3, 2. Which would be better if you actually drew it out to ensure that it's correct, rather than memorizing this formula. Also for the reflection in the x-axis, it's best that you do not memorize the formula, because at times it will not be in the x-axis, where it could be maybe y equals to x, which is a different case, right? So the next one is EE. EE is enlargement with a scale factor of 2 and the original center, which is what we have done at the beginning, which is, so the scale factor is 2, you just have to multiply it by 2, and then again, and there you have it, your last image form. So this is the next subtopic, where we have to determine whether AB is equivalent to transformation BA. At times it will be equivalent, but at times it will not be equivalent. So let's find out in both cases. Right, so here's my image, and we're gonna go ET and TE. So let's find the answer first. So T is translation for -1. We use just the things we learned just now. So 1, 1, and A prime, which is the enlargement with a scale factor 3, would be 3, 3. Next, TE. And our next image would be -9 and 6. And then we'll undergo T to produce -5 and 5. So is ET equivalent to TE? Answer is no. ET is not equivalent to TE. Let's see the next case. So here's my image, and they want me to draw EP and PE, right? But I'll just draw the Alright, let's do EP. P is the reflection on the x-axis, so let's do that. X-axis reflection, so it'll be here. So here's our first image, and then the second image is enlargement center scale factor 2, right? 5, -2. We'll multiply it by 2. Again, 2, -2. And 2, -4. Right, we still have 1 point. 4, 3. -8, -6. Right. So this is our image, final image of EP. Oops. Right. So let's draw PE. PE. So enlargement scale factor 2 from the origin. This is our first image, and then it undergoes reflection on the y-axis. So I'll use a blue one. Reflection, and an image similar to translation EP forms. So the answer would is PE equivalent to EP? Yes, it is. So yeah, there are 2 different cases. One with, so you can actually say that a transformation is equivalent to its reverse form. Alright, next is describing. One important thing is describing the transformation. So by translation, it's easy because you just have to fill in x and y, where x, as I mentioned before, when you go in front, it's positive, and to the back, it's negative. Whereas for y, if it goes up, it's positive. If it goes down, it's negative. Right? The next one is enlargement. So to describe enlargement, you will need the center. So the center of enlargement and the scale factor, where the scale factor can be found with the formula. For rotation, what's important is the direction of rotation, the degrees, either 90 degrees or 180, and the point of rotation, which is either the origin or any point they give you, or the point of intersection. The reflection, on reflection, you need to know the straight. You need to know the reflection line, so the axis of reflection. So for example, some might be y equals to x. Yeah. So for a combined transformation, how do we describe it? So for example, let's do this. So it then goes P1, then P2, right? So P1 is the reflection in the x-axis, so let's do that. label it. Okay, and the reflection in the straight line y equals to x. See, this is different because we haven't seen this. We have been doing on x-axis, y-axis, and things like that. So y equals to x, it's pretty much simple because y equals to x is this line, where any y value is equals to, well, y value is equals to x value. So for example, y is equals to 1, x is equals to 1, see? And to the end, y is equals to 5, x is equals to 5. Right, so that's how you know which line it is. If it's like y equals to x plus 1, you can just plot it by subbing x and y to 0 and 0, and then you can determine the reflection. Right, so okay, let's get back to this. So this is my first image. So right now I need the reflection on y equals to x. So which is here. And here's my second image from here. Right. So they want us to describe fully the whole combined transformation. So right, we remove this and this, remove all this. So right now they want to know from here to here, what's the transformation? And one way we can see it is that you can see that it's actually a rotation anti-clockwise 90 degrees, right? So how do we describe it? Right? So combine transformation P2 P1 is anti-clockwise rotation of 90 degrees about the origin. So that's the combined transformation. Notice that it's different than what's mentioned in P1, P2. So take note of that, because combination is a little bit harder. So you have to do more practice on that. So next subtopic, solving problems involving transformation, which is pretty much enlargement. So enlargement, there is a formula which is area of image equals to k square. Please remember the k square, the square, because a lot of people might forget that, times area of the object, right? So let's take this as example. The center of enlargement is 1, 7, and the scale factor is 4. And how do I determine the scale factor? How do I find it? Similar to what I said in front. Measure this distance. So 13 minus 1, 12. And this again. Oops. Right. 4 minus 1, 3. So 12 over 4, 12 over 3 equals to 4. So here's the scale factor, which is k. So you can sub into the formula. So it's 4 squared, and area of object, then image, right? And I have the image, which is 352. So I'll divide this, and I'll get area of ABCD, which is also my object, which is 22. So that's an example. I hope this video helped you, and please like and subscribe. Thanks.